Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
Wires are used in the fabrication of nearly every type of orthodontic appliance. The simplest appliance, the band and loop space maintainer, is shown here, on through the full banded orthodontic appliance, all utilize wire that is bent and formed into specific configurations for specific purposes. Wires are used in orthodontics mainly for two purposes. First, as springs to apply tooth-moving forces to teeth, and secondly, as clasps to hold appliances in contact with teeth. In order to make these springs and clasps, a wire must be properly shaped in all three dimensions or planes in space. There are four basic types of bends that are used to fabricate orthodontic appliances. The right angle bend is shown here, loops, curves, and lastly, control of plane in space, or flatness. There are certain basic techniques that can be used to make these bends for orthodontic appliances. The purpose of this presentation is to demonstrate these basic wire bending techniques. Wires used in orthodontics are round in cross-sectional shape most often. Now, round wires are identified by their cross-sectional diameter as expressed in inches. As an example here, 0.030 inches is the diameter of this round wire, or 30 thousandths of an inch in diameter. Rectangular or square wires are used with one type of full-banded orthodontic appliance, the edgewise appliance. In the edgewise appliance, rectangular wires, as shown here, fit into rectangular slots in brackets that are welded to bands. Square or rectangular wires are identified by two dimensions. As an example, 0.018 by 0.025 inches. Orthodontic wires are most often made of stainless steel, which is a chromium, nickel, and steel alloy. The stainless steel alloy that's used for orthodontic wire has been formulated to provide the most optimal tensile strength, properties of elasticity, and resistance to corrosion in oral fluids that is possible in a steel wire. Gold alloy wires are also used in orthodontics. These are alloys of gold, platinum, and palladium in varying percentages, and gold alloy wires are identified by a small tag with a brand name on the end of the wire. Gold wires can withstand a lot more manipulation than stainless steel wires before breakage occurs. In other words, they will not fatigue as rapidly as stainless steel. Gold wires are used in those appliance situations where many adjustment bends must be made in a wire during the course of a treatment. Orthodontic wires are bent using pliers that are especially made for this purpose. Now, there are literally hundreds of types of orthodontic pliers with beaks that are made for special purposes. Three of the most basic and widely used orthodontic pliers are the 201 three-beaked plier, the 53G optical plier, and the 139 bird beak plier. The 201 plier has 3 beaks that close together on themselves. Now, the 201 plier will bend a wire simply by squeezing it. To bend a wire with a 201 plier, the wire is placed between the 3 beaks of the plier at 90 degrees to the long axis of the plier beaks, and it is squeezed. By simply squeezing the wire, then, the bend is made. The 53G plier also will bend wire simply by squeezing it between the beaks. This plier has one round beak here and one beak that is concave. The round beak fits into the concave portion of the opposite beak. To bend wire with a 53G plier, the wire is placed at 90 degrees to the long axis of the beaks of the plier, and it is squeezed. And a bend is made. Both the 201 and the 53G pliers are very useful for wire bending, but they have one disadvantage, and that is that they can gouge or nick the wire as they make the bend. A defect in the wire can be created at the spot where the beaks of the plier contacted it. Now, a nick or a gouge in the wire, as shown there, will reduce the diameter of a wire, and it may predispose the wire to breakage at the site of the defect. Most orthodontic wire bending can be done with the 139 pliers. This plier has one round beak, and it is opposed by a flat surface beak. The base portion of both beaks are flat in the 139 plier. To bend a wire with the 139 plier, you hold the plier in your right hand, if you are right-handed, with the round beak away from your chest. You place the wire in the beaks of the plier. Now, it is important when you place the wire in the beaks of the plier that the diameter of the wire that you're bending is smaller than the diameter of the region of the round beak that is grasping the wire. A plier might be damaged if a large wire is bent at the fine tips of the plier beaks. You also must be sure that the wire is at 90 degrees to the long axis of the beaks of the plier. Now, in wire bending, the pliers serve as a vise to hold the wire. The actual bending is done with the thumb and fingers of the opposite hand. Now, to make a bend, the thumb is placed as close to the beaks of the plier as possible, and the wire is pushed over the round beak of the plier. The result is a right angle bend. To bend a curve in an orthodontic wire, you start by placing the wire back in the beaks of the plier, and a portion of the beaks where the round beak is larger. And again, the wire is placed at 90 degrees to the long axis of the beaks of the plier. A curve is actually a series of many small bends in a wire. To make a curve, then, the wire is bent and then slid along in the beaks of the plier until a series of many small bends are made. Now, in this way, you can make a curve that is smooth and continuous. Many times, a curve will start out to be smooth and continuous, and in the end, you will look at it, and it is actually a series of overly bent areas and overly flattened areas. To correct this, the flat base portion of the plier can be used to open up the overly curved portions of the curve by placing the wire all the way back in the plier and squeezing it. The areas that were too flat are simply bent in the usual manner to give them some curvature. And with this technique, you can continue to adjust the wire until the curve is smooth. To bend a loop in an orthodontic wire, you place the wire halfway back in the beaks of the plier. Again, at 90 degrees to the long axis of the beaks of the plier. With the thumb, the wire is pushed right around the round beak of the plier. And a smooth loop is then formed, just to the shape of the round beak of the plier. Orthodontic wires must be accurately formed in all planes of space. There are techniques that can be used to control and correct the plane in space of a wire. Wires are often compared to a flat surface, like a tabletop or a glass slab, to determine if the wire is bent in the same flat plane of space as this one is. Now, ideally, as you're bending a wire, such as this example, the bends are made with control of the plane in space in mind, by keeping the wire at exactly 90 degrees to the long axis of the beaks of the plier as you're making each bend. It is possible to correct the plane in space of a wire. However, and the best example of this procedure is to flatten a wire that is bent out of shape. Now, to flatten a wire, what you're actually doing is adapting it to the flat surface. You start by finding a stable starting point. In this case, the end of the wire and the first bend arm are flat on the table. You can see the point where the wire leaves the table surface. This is the point that you mark the wire with a wax marking pencil. Now, this is a white wax china marking pencil. You can use a felt tip pen, it works just as well. The procedure then is to place the wire in the flat base portion of the beaks of the plier, just to the side of the mark that you made, and orient the wire so that the flat portion is directly parallel to the long axis of the beaks of the plier from the side view. And the wire is simply bent down then until it approaches parallelism with the part that is already flat on the table. Now you try the wire back down on the table, and we see that it has in fact become worse. The portion of the wire that was flat originally up to this pencil line here is now off the table. you know that your wire was flat up until the point where you made the pencil bend, pencil mark. So to correct this, you simply go back and remove some of the bend that you just put in. You know that the bend you just put in the wire is the one that caused the problem. By removing some of that bend, again, the first portion of the wire becomes flat on the table. You try to flatten the wire again now by placing the beaks of the plier back on the wire and bending it a smaller amount. Now it begins to approach flatness on the table surface. We can see, though, as you hold the wire down on the table, that a peripheral portion of the wire is now contacting the table first, preventing this next leg of the wire from contacting the table. In this situation, you make a bend in the wire to get this contact off the table, get that peripheral interference out of the way. You can grasp the wire at any point, actually, on this side of the point that's contacting the table and bend the wire up out of the way. Now, when that is done, we can visualize then that a simple bend at this point right here, the original pencil mark point, will flatten that next segment of the wire. Now the wire is flat on the table up to this point right here. Again, the wire is marked at the point of last contact with the table. And the same procedure is followed, grasping the wire in the flat base portion of the plier, and a compensating downward bend is made in the wire to adapt it to the tabletop surface. And now this next leg of the wire is also flat. This last portion of the wire still is off the table, and so a small mark is made at the spot where the wire leaves the table, and again a small downward compensating bend is made in the wire. As a further demonstration of wire bending technique, some exercise pattern wires will be bent. These exercise pattern wires are designed to develop the ability to make the four basic types of wire bending manipulations: the right angle bend, the curve, loops, and control of plane and space. This first exercise is a series of 3 right angle bends. To start, the wire is placed over the first leg of the pattern, and a mark with the marking pencil is made right at the corner of the pattern on the wire. The wire is placed in the beaks of the plier just to the short wire side of the mark, bending the wire over the round beak of the plier with the finger. The bend is made 1/3 of the way. At this point, you try the wire back on the pattern to determine if your bend is started in the correct position. If you're satisfied that the bend is starting out in the right direction, the plier is placed back on the wire, keeping in mind that the wire must be at 90 degrees to the long axis of the beaks of the plier. And after you have a bend in the wire has to be oriented so that any bend in the wire is directly perpendicular to the flat beak of the plier. The 90-degree bend is then completed by pushing the thumb over the round beak of the plier. The wire is tried back on the pattern then to determine if you have made the bend correctly. This chart illustrates the right angle bend procedure. A mark is made directly over the corner of the wire on the pattern. The beaks of the plier, represented here, the round beak and the flat beak, are placed on the side of the mark. The thumb is placed as close to the beaks as possible, and pressure is applied so that the bend is made 1/3 of the way. At this point, the wire is checked on the pattern or the work model to determine if it's being made in the right spot, and if it's correct, the bend is completed in this manner, and the completed bend will have the mark that you made in the wire directly at the corner of the pattern. Certain problems may develop as these bends are made. If your bend is started too short of the corner of the pattern, in other words, the first segment of the wire is too short, the bend might be moved down the wire by grasping the wire with the beaks of the plier directly over the mark to complete the bend. This portion of the wire then is bent around the round beak of the plier, and this will add some small bit of length to your bend. If your bend was started too far down the wire, in other words, the first segment of the wire is too long, you grasp the wire beyond the pencil mark, and the first leg of the wire is bent back over the round beak of the plier. This will shorten this first leg in the wire and move the bend back. When the first bend is complete, the wire is marked, as before, directly at the corner of the pattern. The pliers are placed on the wire just to the side of the white mark that you made. It is important that the wire be at 90 degrees to the long axis of the beaks of the plier, and that the first leg of the wire that you've bent be at 90 degrees perpendicular to the flat beak of the plier. The bend is made 1/3 of the way, again, keeping in mind always the plane and space of the wire as you make the bend. At this point, the wire is tried back on the pattern to determine if you're starting the bend in the right spot. To complete the bend, again, the wire is oriented in the beaks of the plier, just as before, and the bend is completed. The best way to ensure control of plane and space is to control it as you're making the bends in the wire the first time. Correction of flatness of a wire is a difficult procedure, and it's so much easier just to do it as you're making it. The wire is tried back on the pattern, and this third bend was made a bit too sharp, so some adjustment can be made by placing the beaks of the plier back at the corner and opening the bend slightly with your fingers. Now the wire at this time fits directly over the lines of the pattern and it is flat on all three portions. The fourth bend is used, third bend is used using the same techniques as before. The wire is marked directly at the corner. The beaks of the plier are correctly placed. The wire is oriented in the beaks of the plier. And the bend is made 1/3 of the way. It is tried back on the pattern to be sure that the bend is started in the right spot. And the bend is completed then by pushing the thumb over the round beak of the plier with control of the plane and space in mind at all times. Okay, the bend was not sharp enough yet, so we'll put some more bend into it. Each time you make a bend in a wire, you have to be aware of the plane and space. In other words, you have to orient the wire correctly in the beaks of the plier. The second exercise pattern incorporates all four types of bends in the wire: the right angle bend, curves, loops, and control of plane and space or flatness. This pattern simulates the bends that are needed to make a Hawley labial wire. To bend this exercise pattern, it is best to bend the curved portion first. This is done by making a series of small bends in the wire very close together, moving the plier along the wire and making a smooth curvature. This is a lengthy procedure. It will take at least 20 minutes to bend this curved portion of the pattern. We have prepared a curved portion that fits the pattern. The next step after this curved portion of the pattern is flat and fits directly over the lines is to mark the spot where the first right angle bend for the loop will be. The same procedure is used as before. The beaks of the plier are placed just to the side of the mark in the wire. The wire is oriented at 90 degrees to the long axis of the beaks of the plier, and the wire is kept directly perpendicular to the flat beak of the plier, if possible, to control the plane and space. When you have the wire properly oriented, the bend is made 1/3 of the way. At this point, the wire is tried back on the pattern to be sure that you're making a bend in the correct position. Control of plane of space is important at this time, too. The wire contacts the table all the way around the curved portion, and it leaves the table at the point where you just put the bend in. Therefore, it is a good time to make the correction by placing the wire in the flat base portion of the plier and bending it slightly downward or upward, as the case may be, so that you end up with flatness. Contact here and contact here. The right angle bend is completed. And the wire is again tried on the pattern to determine if the bend was made in the correct direction. The curvature for the loop is marked with the pencil right at the point where the curve begins. The wire is placed in the beaks of the plier about 1/2 of the way, or maybe slightly more than half of the way back on the round beak of the plier. It is oriented correctly, and with the thumb or the finger, the curve is started around the loop. When you have the loop partially bent, you try the wire back on the pattern. Now this loop is being bent too small. There is a method for opening a loop that is too small, and that is to place the beaks of the plier farther into the loop being bent and squeeze the plier and open the loop slightly. This will increase the circumference of the wire in the loop. You continue the bend, pushing the wire over the round beak of the plier a little at a time, and again trying it on the pattern. The loop is still a bit too small, so again compensation will be made by placing the loop farther back in the round portion of the plier, and the loop then will be continued around, the bending of the loop around a larger portion of the round beak of the plier. Now, the loop is bent and it fits over the pattern. The next section of the wire is bent by marking the spot where the next right angle bend should be, and again the beaks of the plier are placed just to the side of the mark. The wire is properly oriented in the pliers with control of plane and space in mind. The bend is made partially to determine that you have the bend started in the correct position, and the bend is then completed by again reorienting the wire in the plier beaks and pushing with your thumb the wire over the round beak of the plier. The loop on the opposite side is bent using these same techniques, and the end resulting wire has this appearance. The wire rests directly over the black lines on the pattern, and the wire is flat on the table surface. There are some problems that should be avoided in wire bending. The first of those problems is damage to the wire from plier manipulation. I'm speaking about gouges or nicks in a wire that are placed in it and may weaken it. Now, you never should bend a wire over the flat beak of a 139 plier. Always bend a wire over the round beak of a 139 plier. The second common problem is that of over-rounding of right-angle bends. If the thumb is placed away from the beaks of the plier, the bend will not be properly formed. It'll be too rounded, as shown here. You want the bend to be confined to a relatively small area of the wire. In other words, you want the wire to be straight as it goes into the bend and straight as it leaves the bend. Placing the thumb close to the beaks of the plier as you're applying the pressure will produce accurate bends. In summary, the main points to remember about wire bending are, first, always mark the wire before making any bends. Second, always place the plier beaks at 90 degrees to the wire being bent. Third, keep your thumb or finger bending the wire as close to the beaks during the bending movement as possible. Fourth, make small bends in a wire and check for accuracy on the pattern or the work model after each bend. Lastly, make the completed bends in a wire perfect in all planes of space before moving on to the next segment of the wire. As a final note, I must mention that the precision of the wire bending in any orthodontic appliance is probably the most important factor in determining the success or failure of that appliance clinically. If you follow the technical methods that have been demonstrated, wire bending can be reduced to a simple, step-by-step procedure that will produce accurate results.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.